Hi everyone. As part of AWS Redshift and Google BigQuery integration in Mule, in this first part of the video tutorial, we are going to see loading data to Redshift and Google BigQuery. So we are going to first connect to Redshift and BigQuery, and then assume we have data in different formats or different types of data, and we want to load some part of it or specific data for types to one destination and other data types to another destination. So to mimic that, let's assume in this case I am going to read CSV and JSON files, and the CSV I will load it to Redshift, and the JSON files I am going to load them to BigQuery. So we are loading the data to both destinations concurrently using scatter gather. As you can see here, we have the read CSV operation from the file module. It reads the CSV data and then it transforms it and inserts it to Redshift. And the second one, we are reading JSON data, and that JSON from file module still, and we are creating dataset table in BigQuery and inserting the data. First I have to come here to IAM and admin, and under service accounts I have to create a service account. I have created already a service account. Just go here and create a service account here. I have done already mine, and also I have to assign appropriate roles to it. So I have assigned BigQuery related roles, including admin, data owner, and BigQuery user. So once you do that, you have to download key from your service account. So if I go to my service account here, under keys, I can create a new key here and download it, because I need this key to connect to BigQuery from Mule. And for Redshift, you just need the JDBC URL from your Redshift account, the JDBC URL, your username and your password. So we can see, to save time, I have built the flow here. And if we start with configuration, with the connection configurations first. So to connect to Redshift, I'm using the database module, and so the connection type, I specified generic connection here, and I have to specify the URL, driver class, username, and password. So these credentials, I have saved them here under configuration, under this config.yaml, and added it here as configuration properties. So basically, you need to connect to Redshift, you need the JDBC URL from your Redshift account, and the driver class is, in this case, for the driver class that I'm using here, it says it depends on what driver you are using. So the driver class here is com.amazon.redshift.jdbc driver, and you have to add Maven dependency here. So for Maven dependency, I just went ahead and copy pasted here. You can search online Amazon Redshift JDBC driver Maven, so it gives this one. So I just copy pasted this. Now once we put the Maven dependency and provided the connection credentials, including the URL, driver class, and username, we can test the connection. So the connection should be successful. As you can see now, it means it can successfully connect to my Redshift cluster. I have also connection configuration to Google BigQuery. So to connect to Google, first to set up this connection configuration, if you don't have it, you have to add this Amazon Redshift connector from Exchange. So just to go to Exchange and search here. To connect to Google BigQuery. For to connect to Amazon Redshift, I am using the default database module. So I'm connecting this using database, not Amazon Redshift, but to connect to Google. I'm using Google BigQuery. I'm using this Google BigQuery connector that has different operations under it. So we can go to Exchange and search here BigQuery. So this is the connector that I am using, and once we add it here, then I have the connection configuration I can show here. So you need the project ID. This project ID, you get it from your BigQuery account once you create your service account, and you have to also this service account key is the key that you download under your service account. So you have to download it and save it in your machine and add it to your configuration file. And also I have also copy pasted it here to under source main resources. This is my key, so I have you just copy it and paste it here. So this one also I can test the connection to see if it successfully connects to BigQuery. So now I can connect to both BigQuery and Redshift, and I have data. I have some dummy data that I want to load to BigQuery and Redshift. So the CSV data is okay. So my data is in here. I have customer data. It is in CSV and JSON, the same data, just for tutorial purposes. It is dummy data. So if I open it, comma separated values like this. So this data I download. If you don't have some data, if you need some data to practice with, you can watch my video in one of my videos. We saw how to create how to insert data to MySQL and Postgres databases, so to use with Mule. I will add a link to it in the description section, a link to that YouTube video in the description section, and you can go watch it and install MySQL. It shows how to it shows installing MySQL and also creating databases. There we created this Northwind database, and under it has different tables for it is good data for practice. It is dummy data, but you can use it to practice with Mule. So okay, let me show the table under it. So we have these different tables. So this customer, the data that I have here that I am uploading, that I am loading to Redshift and BigQuery are this customer data. So let me show what it looks like. So this is the customer data, and I simply exported it as CSV and also as JSON. So that CSV and JSON data, I am here in this flow reading them concurrently, and the CSV data, to read it, as you can see here, I specify the full path and also the data type application /CSV is a MIME type, and also I can add other parameters, including separator, for example. In this case, different key value pairs for CSV. So if the separator is not comma, I just select separator. By default it is comma, but if it is something else, I can specify it here also. So once I read in the CSV data, I'm just transforming it to JSON here, and using the bulk insert operation from the database module. We have this bulk insert rather than inserting each record at a time using for. Okay, so here I'm using the bulk insert to insert the data to the database. As you can see, I want to insert the input parameter is the payload, which is the data, and I have to specify here data insertion. I have provided data insertion SQL query text. So insert into the employees table, and then specify the column types, and then the values will be so my payload in this case is in JSON format with key value pairs. So if I put colon key, I mean, if I put here in this case, for example, colon company name, this one, it knows the key is company name and it is going to get the values corresponding to that key. So this way, we specified under the employees table what the different columns it has are, and also the values that it should insert. It accesses, it gets it using the provided keys. So in Redshift here first, so since this flow is not creating a table for me in Redshift, I have to go to Redshift and create a table. So I have this create table script. So I'm creating employees table. Now this one, it includes different tables, as you can see, different columns, I mean. So if I run this, it is going to create a table under this dev database. Now if I refresh this, I should see employees table here it is. That if I try to query, since now we have not inserted any data to it, there should not be any data. It returns just no records. We just see only the columns. So we have created the table in Redshift, whereas in BigQuery the table creation, since we can create a database and a table in Mule for itself, we have included as part of the flow create a data set and create table operations. So to insert data to BigQuery, what we are doing is here we are reading the data, the JSON data. It is customer.json, specified the full path here, and here I specified the MIME type. It is application slash JSON. And the other thing, very important thing here, is my payload. That is a payload, the data that I read from JSON. I am saving it as a variable here, because when it creates a data set, that payload will be replaced. My payload after creating a data set will be some information about the data set creation in BigQuery. So I'm saving my payload as a variable. I am calling it data, and its value is payload. Here I'm creating a data set in BigQuery. Its name is employee, and also I specify the Google BigQuery configuration. And here I have to specify, to create a table, I need a schema, I need column names. So I have here JSON data, an array of each column that has information about the field name, the field type, and other things. So this is the schema, and when I create a table here, I specify that the table should be under what dataset? Under the employee dataset. So we have this employee dataset. Under the employee dataset, we are creating employee table. So the dataset we can call it something else also. So under the employee hierarchy, under the employee dataset, we have employee table, and I am specifying my connector configuration here, which is a Google BigQuery configuration. And I have to specify also the table fields. When I create a table, I need to specify the columns, that is the schema. And since I have created a variable here, in here I create a variable. This is not a payload, it is rather a variable called table schema. So here when I create a table, to access that schema, I do vars.table schema. So here vars.table schema are the table fields. Then finally it inserts the data to BigQuery. We specify the table ID and the dataset ID, and also what data to insert. Okay, well, where is the raw data coming from? It is coming from vars.data. And where is this vars.data? Because the payload from reading the JSON, I saved it here as a variable called data, and in here when I'm inserting it to BigQuery, I can specify here under the rows data as virus.data. So as I said again, the reason that we save the payload as a variable here is because once it creates a data set here in BigQuery, then our payload will be overwritten. So creating a variable that contains the payload in here helps us not to lose our payload. And finally, this logger, it should print to the console data successfully inserted into Amazon Redshift, and this logger, it should print into the console data successfully inserted into Google BigQuery. And finally, I'm setting a payload here. If everything here is fine and it reaches at the end, then since I have a listener here, and since I am going to send a request just from Postman or Arc, then the response that I should get, if everything works fine, should be data successfully inserted into Amazon Redshift and Google BigQuery. So in let me show you my. So in BigQuery, this is my project ID. Under this project ID, it will create a data set called employee, and under that employee, it is going to create a table called employee again, and it is going to insert the rows or the data into that employee table. So now let me run this project, and once it deploys, then we are going to send a request from Arc. So let me check what the path name here is. So the path name is just load. Once this is successful, once it deploys, I will go here and let me make this ready until it deploys it. So port is 80, 81, and then load. Let's clear this. We can go and send this. So let's first check. As you can see in Google BigQuery, this is my project, and under this project I don't have any data. I don't have any data set, I don't have any table. And the same thing in Redshift also. I have created this employees table, but it doesn't have data in it. The reason that I'm creating a table in a Redshift is because my flow it is not creating a table for me here, whereas for BigQuery I'm creating the data set and the table in this flow. So now let's send a request. Once we send a request, we should get some information that data has been, as you can see here, it says the response code is 200. That means it worked fine. And here the response also, we see data successfully inserted into Amazon Redshift and Google BigQuery. This is what we wrote in this payload, what we have in this payload. So that means everything went ahead appropriately up to the end. And now if you go to Redshift and run this query again, now we should see data in Redshift. It should have inserted data. We should see data inserted to Redshift. So as you can see, it has our project, our Mule flow has inserted the data, the CSV data to Redshift, and also let's check if the JSON data has been inserted to BigQuery. So the first thing is, did it even create a data set and a table? Let's check. If we refresh this, under here, under my project here, you can see it has created an employee dataset, and under that dataset we have this employee table. And if I click here, I see the different this is the schema, the different columns, the data type, and if I just click here preview, we see data has been inserted to Redshift. So in this tutorial we saw how to connect to Amazon Redshift using the database module, and to Google BigQuery using the Google BigQuery connector. And we sent data, CSV data, we loaded CSV data to Redshift and JSON data to BigQuery. This kind of application especially becomes useful when we have different data sets coming in continuously. Let's say every day we are getting different kinds of data, and some part of it, some data types based on the importance, on the security requirements and so on, we may want to load it to somewhere, and the rest of it we may want to load it to another thing. So in this case we loaded data to Redshift and BigQuery, and in another tutorial we are going to see how to extract data from both Redshift and BigQuery and enrich them, process them, and transform them in MuleSoft. This is enough for this tutorial. If you like this video tutorial, you can get more video tutorials from my website, and also I have added many projects, MuleSoft projects, to my GitHub repo. I will add links to my GitHub repo and my website to the description section, and you can check them out.